Welcome to The Explainer. So, today we're diving into something pretty wild, a theory that tries to build our entire universe, all of physics, from, well, literally nothing. And it all kicks off with a really simple idea. Okay, so if you're going to build a theory of everything, you've got to start simple, right? The simplest possible universe. So, let's do a little thought experiment. Just picture it. Two marbles. And that's it. They're just floating in this huge, empty void. Now, how would you even begin to describe them? All right, to get a handle on these marbles, first we need to define the reality they're actually in. And let's start with what feels like common sense, the classical physics of good old Isaac Newton. This gives us a really neat, predictable, almost clockwork universe. So, in this nice and simple universe, space is, well, it's just a static backdrop. Think of it like a giant invisible sheet of 3D graph paper. You've got your X, your Y, and your Z coordinates, and bam, you can pinpoint the exact position of each marble at any given moment. Super simple. And time? In this view, time is totally absolute. There's just one universal clock, and it ticks away at the exact same steady pace for both marbles, for everything in the universe, no matter what. Kind of like the steady click-click-click of frames running through an old film projector. And then, finally, we've got mass. We usually think of it as the stuff an object is made of. The more stuff a marble has, the harder it is to get it moving or to stop it. That's its inertia. In this classical picture, mass is just a fixed, fundamental property of the marble. Period. So if you put all this together, this clockwork view leads to a really profound conclusion. It means if you know the exact position and motion of those marbles right now, you can predict their entire future with perfect accuracy. The whole universe is just a predictable machine. But come on, is reality really that simple? Well, as it turns out, nope, not even close. The 20th century came along and just completely shattered that predictable common sense picture. It gave us three revolutionary ideas that showed us a universe that's much, much stranger and honestly way more interesting. Okay, so let's break this down. Pillar number one. Einstein's theory of gravity. It showed us that space isn't just some static stage. It can actually be bent and curved by matter. Then you have special relativity, which proved that time isn't universal at all. It's relative. It actually depends on how fast you're moving. And then, oh boy, then comes quantum mechanics, which just turns everything on its head. It tells us a particle doesn't even have one definite location. It exists in this weird cloud of probabilities. All of a sudden, reality just isn't so certain anymore, is it? So what does this all mean? It means that our nice, simple, common sense picture of those two marbles, it's completely, totally wrong. The universe is not a predictable machine. It's this dynamic, relative, probabilistic place. And frankly, it's way, way weirder than we could have ever imagined. So, faced with all this profound weirdness, the theory we're exploring proposes a really radical shift in thinking. To make sense of this new reality, it says we have to change our most basic assumption about what things are even made of. See, this theory challenges that core idea we all have of matter, that it's made of tiny, solid little points, like microscopic marbles. It asks this incredibly powerful question, what if that's just not true at all? What if the universe is made of something else entirely? And the answer it gives is, wow, it's fascinating. The fundamental stuff of reality isn't particles. It's something else, fields. These are continuous things that fill up all of space. So the universe isn't a collection of tiny little dots. It's more like this incredible tapestry of overlapping, vibrating fields. So think about it this way. In this view, an electron isn't some tiny little ball. It's a ripple. It's a little concentrated vibration in a giant electron field that stretches across all of space. And look, this isn't just some random idea pulled out of thin air. Our best theory of the subatomic world, the standard model of particle physics, is already a theory of fields. This shift in thinking from particles to fields, that's the key that unlocks this whole thing. Okay, and this is where the idea really builds to a truly startling conclusion. This is the part that tries to tie everything together: gravity, quantum mechanics, and the very nature of matter itself. Get ready. All right, here it is. The most profound, the most radical claim of the whole theory. Those little ripples in the fields, those quanta that we call fundamental particles, are actually, mathematically speaking, the same thing as microscopic, rotating black holes. Let that sink in. An electron, in this theory, is a tiny black hole. Wild, right? Now, the logic here is actually incredibly elegant. The idea is you start with nothing. I mean, literally nothing, just the vacuum of spacetime and its fundamental rules, what physicists call symmetries. Now, when you take those rules and apply them everywhere, the equations for gravity and curved spacetime just naturally emerge. And here's the kicker. The solutions to those equations aren't just empty space. They describe things that have the exact properties of particles: mass, spin, the whole shebang. So particles aren't things in space, they are literally properties of space itself. Okay, so if this mind-bending theory is actually true, how does it explain the history of our universe? From the Big Bang all the way to today. Let's take a look at that whole cosmic story, but through this totally new lens. So, starting with the Big Bang, you can see the whole cosmic story as just the evolution of these fields. First, the Higgs field kicks in, giving these tiny black hole particles their mass. Then, the strong force starts binding the quark black holes together, forming protons and neutrons. You fast forward about 377,000 years, and the universe finally cools down enough for the electron black holes to start orbiting the nuclear ones, and boom, the first atoms are born, and light can finally travel freely through space. So think about this journey. We've gone from two simple little marbles all the way to a universe built entirely from the rules of empty space. This theory leaves us with one last, really profound thought to chew on. If we and everything we see around us are all just complex patterns that literally emerged from an empty vacuum, then what does that make us?